And here we go. So the way this is going to work is I'm going to primarily talk about the GT, and G-Air you'll see on the left, and then the NX on the right. The idea behind this organization on this presentation is you'll see kind of in the top right little icons. What I want to do is talk about the features, or what I'm calling here the requirements. That is your requirements on what you need from the video scope to get the job done. So I have these very relatively general concept requirements here on the left. What I'm going to do is take those and describe what we have seen is needed, which requirements are needed per application. So I'll go through the thermal power, nuclear power, oil gas pipeline, and briefly introduce these requirements and where we see their application being used. And then I will go into detail on the actual requirements themselves. So the way this is going to work is essentially, here is what is being used in this specific application, and then I will describe that which is being used. And then, of course, close this event with a live NX demonstration. Nothing scheduled for that. That is going to be completely crowd-driven. So first off is nuclear power. Some of the basic requirements, and when I say basic requirements, these are really specific to nuclear power, and all of these from here after will be specific to those applications. Of course, there are some basic general requirements that all videoscope users need, which we will go over, but again, these are just highlighting per application. Radiation hardened design, of course, is can be of a concern. We have a radiation resistance report on the G-Air and NX. I have an example of that, or a screenshot. Basically, we know how much radiation our videoscope can take before it starts to degrade, so that you can have a pretty good indicator of how long the videoscope and the chip specifically at the end of the videoscope will last. The LED on the tip adapter, this specifically points to the G-Air. The G-Air is our long length scope. More on that later, but the G-Air comes in lengths of 20 and 30 meters long. The NX and others are only about 7.5 to 10 meters long as their maximum length. The G-Air, because we expect it to be used more in the nuclear industry, we put LEDs on the tip adapter. The reason for this is if the only alternative would be to have a fiber optic cable in the insertion tube to carry the light to the end of the insertion tube. Radiation can, over time, produce what is called a browning effect on that light guide, because it's effectively glass, and any sort of glass does degrade over time. It's called browning, but what it really means is its light transmissibility goes down, and so the brightness goes down. But the LED will stay maximum brightness until the very end. Ensuring inspector safety, remote operation, and live image streaming. This, in a nutshell, simply means that there are situations in the nuclear inspection industry which require inspection of a hot area. We do have the capability of using the scope and showing the scope remotely, so that the inspector does not have to be in relatively hot areas, or at least minimize the amount of time that they are in those areas. Third is probability of detection. We have a bright light source, high quality optics, wider. This is one of the requirements that is not specific to nuclear power, so you'll see this more often. So I'll go into more detail on that in a moment. Inspection efficiency. So again, this is a kind of a general requirement, but there are specific subsets in this requirement for each application. For nuclear industry, interchangeable scopes is useful because you may not always need the 20 meter or the 30 meter option. We have shorter length scopes for our other models, as well as it is a tough environment. So whatever you put into a radioactive environment will degrade over time. So having a spare scope is useful instead of having an entire spare video scope system. And then long exposure for the nuclear power industry and many other industries. If you're looking in a large containment area or a large container, you can set up the long exposure and effectively see many, many feet away with minimal amount of light. So this is these are the main features. I'll go through a couple more applications. Quick note that I do have the description. Basically, everything I described so far is in full detail on the right. I don't go over this here live because I don't want everybody to read this instead of listen to me speaking. So the reason why this is in here is that we will work on distributing this file later for you to review after this, if you'd like. Thermal power. Some of the same basic requirements, but the actual features inside of those requirements do change. Number one, pneumatic articulation. This is, again, specific to the G-Air. The G-Air has a 20 and 30 meter length scope option. Our other scopes are 10 meters and shorter. And I will go into detail later on what that looks like. But effectively, the G-Air requires a different type of articulation system because 20 to 30 meter length insertion tubes cannot use the traditional articulation system and give you enough articulation angle in order to do your job. So that's why the G-Air's system is different. Tapered flex, very important for longer length video scopes. What this basically is you have the end of the insertion tube where it articulates and where the actual camera and light source is. And then you have this long, again, I'll just say 30 meters, about 100 feet of insertion tube. The end of the insertion tube where the articulation section is, you want it to be flexible because that is the first point of attack, so to speak. Whenever you go around the bend in a pipe, that is the first portion of the insertion tube that will go around the bend. So it does need to be flexible. If you maintain that same flexibility throughout the entire 30 meters, it will become difficult to push the insertion tube down the pipe. So imagine you have all 30 meters of the insertion tube into a pipe and you have already gone through 3 or 4 90-degree turns. If you maintain that same flexibility, you will end up pushing the insertion tube and it will start to what we call kind of bunch up. Imagine trying to push a rope down a pipe. So what tapered flex is there is the end of the insertion tube with the where the tip adapter and articulation section is very flexible. The insertion tube becomes more rigid the closer it gets to the user. So as you insert the insertion tube, you get more rigidity out of the insertion tube, which helps you push through more turns and more bends as you encounter them. Probability of detection, again, bright light source, high quality optics, and wider. I can talk more at length on high quality optics and wider. Basically, pictures are worth 1,000 words with regard to those. Bright light source, I will say that the G-Air specifically, again, has a large macro LED in the tip adapter. The light from that is definitely very, very bright for what you're using or needing. The NX has one of our brightest light sources. It is a laser diode in the base, and that light travels through the fiber optic cable in the insertion tube. And then the GTGX also has a macro LED like the G-Air, but it is located in the base like the NX. 220-degree tip adapter and distortion and correction. Again, this is one of those pictures are worth 1,000 words coming up soon, but basically this will allow the inspector to see more of what they need, primarily for weld inspection. So 220 degrees means that this tip adapter can not only see directly on the side of its tip, but it can actually see slightly behind itself. So you can see an entire orbital weld in one image, which helps for really helps speed along weld inspection. Navigation functions. This is numbers 1 and 2 are specific to the G-Air. And we're very excited about the navigation functions here because we have some new interesting features. Again, pictures worth 1,000 words. Let's hold off on describing too much there until I get to the slide specific to that. And then video recording, very simple, easy to use video recording on all GTGX, NX, and GAir models. Just the simple, quick push of a button.
Hey, Charles, we do have a question here. How can you view the inspections remotely?
So again, I have more information on that coming up, but I will briefly say that we have a couple of different options. One is we have a wireless streaming option where all of our units except for the NX, so the GTGX and the GAir, can wirelessly send a signal so that a mobile device such as a phone or a tablet can connect to it up to 70 feet away. That's 70. And so they can basically see the live image on their unit or on their mobile device. That's the wireless option. On the GAir specifically, we have the option of viewing the scope or the screen of the scope 100 feet away through a video out cable, basically a basic HDMI cable with a repeater. So you have the wireless option and the wired option. The wireless is 70 feet. If you're going through any sort of walls or doors or anything, that of course reduces, but the wired option is 100 feet away.
Thank you.
Oil, gas, and chemical. First one, easy to reach features. We've effectively gone over 1 and 2, so I'll skip those until we get into more details later. Guide head and push rod. The guide head is a new feature, again, specific to the GAir. The push rod is also specific to the GAir. The guide head is essentially an accessory that goes on the end of the tip adapter that is of a specific shape that actually helps the end of the insertion tube go around a bend in a pipe. So when you're pushing an insertion tube through a bend in a pipe, you're articulating a little bit to try to help the insertion tube, but the bulk of the actual movement is from you pushing the insertion tube and the insertion tube effectively rubbing against the inside curve of that bend. This guide head is of a specific shape that actually promotes and helps the insertion tube slide around that bend. And then the push rod, quite simply, is a slightly more rigid rod that you can attach to the end of the GAir in case the tapered flex is not rigid enough in your specific application. Measurements. We, again, have more information on this later, and if anybody would like, I can actually show the measurements, all of these features here with the NX live after this presentation. Spot ranging is very important and very, very useful. Basically, this is a way for the inspector to see if their measurement image is going to be a good one before they even take an image. So this is in the live view as you're actually viewing and doing your inspection. You can quickly see if your measurement is going to be a good measurement and easy to measure. And if it's too far away, it will tell you. And if there is any specific part of the image that is an issue, you'll see that live. So you don't have to take an image and then go and then find out that it's not a good measurement image and then try to go back and take a new image. Super wide stereo. This is, in a nutshell, stereo measurement available on the GX and the NX. And the super wide is specific to the NX. What this basically means is that the NX has a wider field of view. You can see more with the measurement tip than you can with other models, which most certainly makes the measurement easier, so you have to do less searching with your measurement tip. And then 3D modeling. Another one of these pictures worth 1,000 words. So I have a picture on this as well as being able to demonstrate this later. This helps the inspector know where they're inspecting on the actual item in the real world. Basically, they're able to see a 3D model of what they're measuring and see the points being positioned on that model. Inspection efficiency, sharpness control, and saturation control. This helps you can change how sharp you want the image. I personally enjoy just the sharpest image possible. And saturation has an effect and can change colors such as reds and blues for corrosion and heat affected zones. We've seen the saturation control being very useful in those environments. 220-degree tip adapter, we already discussed, and oil clearing tip adapter. This is something I'm very interested in and excited about because something we came out with 2-3 years ago, and the reception has been so fantastic that virtually every tip adapter we're now creating and designing from here on forward has this oil clearing capability. It is basically oil clearing by way of capillary action. So I will say this is oil clearing, not oil cleaning. The point here is that it does not clean the tip adapter, but if you do encounter oil at the end of the tip adapter or near the end of the tip adapter, this clearing capability means that you can still do the inspection even if you have oil on your tip adapter. In the past, the oil would bunch up and due to surface tension kind of have a bubble or drop on the lensing, which would distort the image enough that you couldn't do your inspection. No longer an issue with the oil clearing tip adapter. And pulsar pick, this is an umbrella term that refers to many different features underneath it, including controlling the light source, gain adjustment, exposure settings, all of that. I'll go into detail later, but basically the main point here is that in previous older generation video scopes, the inspector had to go in and change a lot of settings in the menu. Now, all you have to do is press up or down on the brightness setting, and pulsar pick takes care of 5 different features in the background. So we are back to the beginning and basically talking about in detail all these specific features. So first off is the radiation resistance report. For the NX and the GR only, we have this report that not only gives the actual radiation dosage amount, but shows you what happens at that amount, at those radiation dosage amounts. So you'll see on the right here images from the chip, and down at 30,000, the chip actually fails. But more importantly, we can show representations of what the image looks like before. Even though the chip fails at a very high radiation level, it will be significant to know if you can actually do the inspection beforehand. LED on the tip adapter, GR only. Again, this is for radiation hardened design. You see pretty straightforward example right here. So remote operation from 100 feet away. This is GR only. I mentioned the live image streaming, so let me talk about that quickly first. The GTGX and GR has the option of adding a live image streaming capability, basically being able to see what you see from the scope on your mobile device up to 70 feet away. Note that this is only streaming. This is a one-way street. This is the video is coming from the scope to the device. The mobile device essentially uses an app, so you can take pictures on the app and then send those images from that app directly. There's nothing stopping anybody from doing that. I personally would recommend not doing so because you are at the whim of the bandwidth of that wireless connection. So it is possible that you're not getting the best quality image if you're using this, if you're taking a picture of this wireless option. We have another wireless option that allows the scope to send the actual image file wirelessly to your mobile device. So you can both stream the image and also receive the native file so that you are guaranteed on getting the highest image quality. Remote operation from 100 feet away basically has 2 pathways. One is the wired, call it one-way street of video of sending the video through this wired HDMI connection. So you can have a monitor 100 feet away and see what you see on the scope. We also have a remote controller, handheld remote controller that plugs directly into the G-Air, and it uses a USB connection. So we also have USB repeaters, such that you can, those repeaters and that USB cabling can be 100 feet away. So the inspector can see the scope, see what is on the live screen of the scope, and they can use the handheld remote control to actually control the G-Air. This is the big difference between these 2 points. The point on the bottom is only image streaming. The top point, you can not only see the image 100 feet away, but you can actually control the scope. So you can effectively do everything you need on the scope 100 feet away, except for, of course, controlling and manipulating the insertion tube going in and out. But you can articulate. You can just not pull the insertion tube in or out. Interchangeable scopes, relatively straightforward and easy to understand. The idea here is that you have the NX on the left, the GX in the middle, and then representation of the G-Air scope on the right. On each of these models, you have the option of having a base and different scopes. Different scopes in the sense that you can have one scope that is 6 millimeters, 10 meters long, and then another scope that is 4 millimeters, 3.5 meters long. And then you can choose the scope that is right for your application. Or if you're in something like a tough radioactive environment and know you're going to be ruining scopes, you can have 2 spare 30-meter scopes, let's say, so that when one of them goes down and degrades, you can simply grab the other replacement scope that's on the shelf. And the point here is that you can then just replace the scope. You don't have to replace the entire system. Next, 220-degree tip adapter and distortion correction. This is on the G-Air only. A picture of this 220-degree tip adapter is in the top right, and you can see the lensing in the top right of that tip adapter has somewhat of a bubble on it, and it is slightly even raised, which is why you see the 2 tabs, 2 metal tabs on either end. That's to protect the glass on this special lens. So 220 degrees refers to the field of view, the angle at which you can see the environment from your tip adapter. So the tip adapter can actually see behind itself, which is significant and interesting. But we had this tip adapter in the past, and what we found was that it is useful, but it is useful in very specific applications and situations. So not too many people wanted to do an inspection with the 220 and view an entire orbital weld with the 220. They would want to see the orbital weld with the 220, take it out, put a new tip on, and then do the rest of the inspection. With the G-Air, you can now, as you can see on the bottom, we have this distortion correction, which not only changes the fisheye distortion. You'll see with the distortion correction off, you have an extreme fisheye. With the 220 correction on, it effectively smooths out that image over the entire screen so that you get rid of that fisheye effect. These other two are new and interesting because what you're effectively doing is turning this 220, taking this 220 and turning it into a 180-degree tip and then a 120-degree tip. So this is all done digitally in the scope, in the menu structure. So you can do your inspection, use it as a 120 tip to do a standard inspection and use it to navigate. And then if you see a weld, you want to have if you want to see the entire weld in one image, you can change it to the 220 quickly without having to take the scope out and change tip adapters. Lastly, under inspection efficiency are some new navigation functions. These are all G-Air specific. So I will point out on the top right image, first the length indicator. Integrated, that is standard with the GR, you have this length indicator where as you pull the insertion tube out, you can see how much of the insertion tube has been put into whatever you're inspecting. So that if you start at 0 and you can change, you can essentially set back to 0 at any point during the inspection. But if you start at 0 when you, let's say, put your insertion tube inside of a pipe underground, you can then go and do your inspection. And if you see something, if you see an issue that you need to manage, you can see and know exactly how far along that pipe it is because it has the indicator right there. Directly below it is the gravity indicator. This is comes from a sensor, a gravity sensor in the tip adapter. Basically, this indicator is for those of you who have seen or any experience with a flight simulator software. This is very similar to a flight simulator software where you can see what's called the horizon, the line in the circle, and then the blue section represents the sky, and the brown section represents the ground. So this gives you a good indication as to the orientation of the tip adapter relative to the horizon. Also, if you see all blue, that means the tip is pointed up. All brown means that it's pointed down. One new feature that we've never had before is the auto image orientation. So the GR can use this gravity indicator, gravity sensor information, and automatically rotate the image so that the blue portion of the sensor is always pointing up. So no matter how you twist and turn the insertion tube, the image you see on the screen is always going to represent up on the screen is true up and down is true down toward the ground. Next, further for inspection efficiency, video recording. Pretty easy, straightforward. We have on the NX and the GR, the freeze and the record buttons separate. That makes it simply easier to take a picture and take a video. To take a picture on the NX, you simply press the button, the record button, and to take a video, you hold it down for about a second. Pretty straightforward. Oil clearing tip adapter. This is with the GX and the GR only, and only with non-stereo direct view. Not on stereo tip adapters because the real estate is limited due to the dual lensing, and also not on side view tip adapters for the same reason. So that basically this is all on the standard direct view tip adapters, which is what most people use for their inspection. So I have a quick little video here, and you'll see on the video the lensing in the center and then the LED on the bottom. And then the marks on either side of the lensing are grooves that are there to wick away the oil through capillary action. So you'll see this drop of oil being placed on the actual lensing. In the past, when that drop was placed, it would either sit on the lens or maybe cover the lens. As you can see, it is being pulled away from the lens. There's still the chance of the lens being covered, but it will be covered in a thin film so that it does not actually distort the image other than maybe some change in the color tinting. But this is very important and very useful because imagine doing your inspection for 20 minutes, having 20 meters or 30 meters of your insertion tube inside of a pipe, and then you get oil on your lens and you can't see anything. You have to pull the entire scope out and then clean the tip adapter and try to find where you were. This dramatically minimizes that requirement. Lastly, on inspection efficiency is pulsar pick. There's a lot of information here, and again, we can share this file later. But the main point is that there are 5 major features that the video scope on all of our current models do automatically in the background. All of our video scopes mentioned here today have a pulsing light source, which means that the actual light pulses at different frequencies. That pulsing does have an effect on reflection and what we call halation. So the pulsar pick effectively controls that pulsing to get a better image. If you crank the brightness all the way up, that pulsing turns into full illumination, so no more pulsing at the higher brightness levels. It also automatically adjusts the actual intensity of the light source automatically in the background. Gain control, it affects automatically. And then lastly, as you'll see on the graph right here, when you turn the brightness level all the way up, you start to experience higher exposure rates. And then at the highest brightness level, you have our high exposure mode. So if you're in a large cavity and you need to see 20 feet away and the only light is the light coming from the tip adapter, you can crank it up to a high exposure mode and you really can see a cavity 20 feet in diameter and pretty clearly on what and you can pretty clearly see what is on the other side.
True field.
Sorry?
I was going to say, we do have a quick question here on file formats. What file formats are the images and videos files saved as? Do we use standard files or are they Olympus specific file formats?
They're very standard, JPEG and AVI.
Thank you.
So JPEG for images, AVI for movies. Now, that is the standard format. You can view that with any sort of image or video software available. However, there is metadata in the image file as well as the movie file. So on our website, olympus-ims.com, we have software, free software, that is called InHelp Viewer. And what that does is it's a free software where if you view our images with that software, you can see all of the features or all of the settings that the scope was set at that time, as well as things like which tip adapter you were using. What's more important is if you take a stereo image from the scope, that stereo image will still be a JPEG, but you can remeasure that stereo measurement picture using our free software. And again, this is all based on the metadata in the file. So that's the only proprietary aspect of it, but the actual viewing of the image and the file are standardized formats.
Thank you. And we actually have another question on the pulsar pick. Is the pulsar pick standard on all systems or only on the G Air?
Pulsar pick is standard on all of our current major models. I'm not even mentioning the G Lite today, but that is another model video scope we have. Pulsar pick is on that as well. So it is now on all of our major video scope models. We only have one model called the TX, which is a very, very small diameter insertion tube that does not have the pulsar pick.
Yep.
And the next slide has a audio, which I am unaware if it's going to come through the system.
Electric scope tip articulation enables users to easily maneuver to
so are you
True field.
So are you hearing audio from the video?
Yes, we are.
Electric scope tip articulation enables users to easily.
Okay, so that is basically just a quick video showing the actual articulation, what we call true field. True field articulation happens by way of servos on the NX and GTGX. That is, as you manipulate the joystick, you are manipulating servo motors that pull wires that go through the insertion tube. So we have 4 wires that represent up, down, left, and right. And depending upon where the joystick is pointed, the servos pull on either 1 or 2 wires at a time. Another part of the servo system is it's not just pulling the wires, but it is sensing how hard it needs to pull the wires. over time, and this is just the situation in the real world, that wires stretch over time. So the more these wires stretch, the harder the servo motor has to pull in order to achieve the same maximum articulation. There's also in the servo, in the NX and GTGX system, spring system with our articulation, so that it is still recommended not to lock the articulation system. But if the articulation system is locked, that is, if you press in on the joystick, when you let go of the joystick, the articulation will stay at whatever angle you left it at. If you have this sort of angle on the end of the insertion tube, and then you pull it out of a system that has maybe a sharp edge or a hard edge, it will rub on the inside of this insertion tube. And over time, that can wear down unnecessarily so on the braiding here. But our articulation system does have a spring-loaded kind of safety feature, so that this actually gives way as you're pulling back out, as to not give undue stress on the articulation cables. The G-Air has a different articulation system because the scopes are 20 and 30 meters long. 30 meters of articulation cable is too long. There's too much friction, and so the articulation angle would not be enough in order to perform an inspection effectively. So what we did is we have a very small, compact air compressor in the base of the G-Air. That air compressor sends compressed air through 4 very small tubes throughout the insertion, along the insertion tube. And then there is this complicated pneumatic system in the articulation section that, as you articulate, that compressor controls the compression of the air in those tubes at the end to actually achieve the articulation. Tapered flex, I mentioned before, pretty straightforward. It is, the insertion tubes are more flexible here at the end of the insertion tube and more rigid the closer they get to the user, to help with the pushing power of that insertion tube. Guide head and push rod. So the guide head I mentioned before, this is the shape that I specified as a very specific shape. This attaches to the end of the insertion tube so that the tip adapter is flush with the end of the guide head. So this shape, and when we did this design, we looked at many different types of shapes and found that this shape actually helps the most. One, it keeps the tip adapter off of whatever you're of the piping or whatever you may be inspecting, so that you're rubbing on the tip adapter less, which is always a good idea. And second is that it just simply helps slide the insertion tube around bends. And then push rod. This is essentially just an adapter that connects to the end of the insertion tube, and then you have a more rigid kind of push rod that you can attach to this adapter to add more rigidity to the insertion tube. So you'll see here, and you'll see that it can open up, and then the actual rod attaches to this recess section. The insertion tube goes in, so this rod effectively compresses itself, grabs the end, near the end of the insertion tube. It's recommended not to put this on the articulation section, primarily because you're going to need that articulation section to move around. So you can place it a few inches away, and then essentially place this down into there, and then screw the adapter back on so that it does not slide out. And then this adds more rigidity to your insertion tube. Bright light source. So Laser diode on the NX, as I mentioned. So laser diode in the base, the light travels through a fiber optic cable and then comes out the end. Just like the NX, the light source is in the base, or the handle, let's say, and the light travels through the insertion tube and out the end of the tip adapter. The GTGX actually has replaceable light sources, where this is the actual light source. The bulk of it is a heat sink, as you can see. We have, of course, the standard white light source, but we have ultraviolet and infrared options there. This is a good image of showing the difference of a previous generation and a current generation. So this image was taken with an NX, and you can see that you can see much farther down the row of blades as you can here. High quality optics. Olympus has been in business for 100 and I guess over 100 years now. We started off as an optics company, and we still make our own optics and lens systems. And so we're very, very proud as to the very high quality optics we can achieve, which is extremely difficult with video scopes, because of course we have to have a very high quality lens system in an incredibly small space. So having high quality optics relates directly to not only a better image, but also tighter focus and wider fields of view, so that your inspection can be much easier and quicker. The wider system is essentially a more complicated or advanced gain adjustment system. So when you normally crank up brightness or gain on a picture, you affect the entire image. If I crank up the gain on this image, I will be able to see the dark area, but I will also wash out this area that is not dark. So wider is a happy medium where it only affects the dark area. So when you turn wider on, it does not increase the brightness of the area that is already bright enough. It only affects the dark area. So lastly is measuring with confidence. Spot ranging. Again, I can show this on the actual NX Live, but essentially this is a reticule that shows up on the live screen and gives you not only the actual distances at these points, but gives you a color rating. So right now, I know that if I'm measuring in this area, I have a green rating, which is a reliable measurement. If I want to do any measurement out here, I know immediately that maybe I want to get a little bit closer, or angle the tip adapter so that this is actually closer. 3D modeling only on the NX. So these are some really good pictures of a 3D model of a weld. So this is the 3D model of a weld with the actual image stretched over the model. This is what we call a color depth mapping, where the colors correspond to the distance, in this case, the distance from the tip adapter, so how far away this portion of the welding is from the tip adapter. And then down here, you can see that on the stereo image, we created a reference plane with 3 points. The color mapping, the colors represent the distances relative to that plane. So very quickly, let me briefly show one major benefit. So we have a picture of a weld here. Now let's imagine we're trying to measure undercutting along the edge of this weld. If I look there, and even on the side of this weld, everything looks like it's relatively fine. My reference plane is on my base material so that my plane is flat. So what I want to do is I can take this measurement point and basically drag it along the entire weld. And if I ever get a negative value, that essentially tells me that that portion is below my reference plane, which is my base material. So that is then measuring the undercut of the weld. So I can either drag it along the entire weld, or I can turn on color mapping. And with color mapping turned on, I can see all of these hot spots for undercutting, specifically this dark red spot right here. So I know and I can see that it's right next to this point, which means that it is this point right here. So instead of having to drag my cursor all along, I can focus on this area to see and actually measure the deepest undercutting. So is there anything specific that anybody would like to see with the NX? If not, I will go directly into maybe taking a stereo measurement and showing and creating a 3D model.
We have two questions here for you, Charles.
Sure.
First one is, do any of the units require annual calibration?
Good question. No, they do not. The NX or NX and GX are capable of stereo measurement. Calibration happens, but it happens at the factory before the unit is shipped out. So the calibration has already been done. Because these are static systems, no recalibration is needed or even available, again, because they're static systems. The way that works is essentially, if something were to happen to the measurement system, it would happen in a way where the measurement is simply not available. There is no creeping or slow change to the measurement results.
Thank you. And our next question here is, what is the accuracy of measurements on the iPlex NX?
Another good question, and I'll try to tiptoe around and be as political as I can without actually giving an answer, because we officially don't give out accuracy ratings. And the reason for that, and this is going to sound like I'm, you know, it's a cop-out, but the reason for that, honestly, is when you take a measurement on a video scope, regardless of what model or brand it is, you are not taking a measurement of a weld. You're not taking a measurement of a crack. You're taking the measurement of a picture of a crack. The scope is not smart enough to do the measurement. It requires an inspector. So because the inspector is in between the actual crack and the image, any accuracy ratings will rely heavily on the actual user picking the right point and getting close enough to get a good measurement. With that said, that's the official line. With that said, I have no issue saying that I myself have personally seen inspectors who have many years experience video scoping, and if they have an NX and they are close enough, 1,000th of an inch is definitely a reliable measurement, or something you can expect. And one more point about measurement and calibration I forgot to mention before. No recalibration is needed. However, all of our stereo measurement systems, regardless of the model, come with what we call a check tool. That check tool is a small little block with a very small piece of ceramic and 3 dots on that ceramic plate. It's ceramic because ceramic has the lowest coefficient of heat expansion. So it will, once the 3 dots have been laser etched, the distances between them will never change. So the check tool is there for you to put the insertion tube in and just check. Just make sure that the measurement is still reading exactly what you expect.
Thank you.
So let me run into this stereo real quick. I'll generate a quick 3D model and show how to use 3D modeling with stereo measurement. You'll see here the spot ranging, and you'll see that it's live. I have this set up kind of everything stationary, but you'll still see these numbers kind of creep and pop around based on the pipe slightly moving around. And you'll see each value is the Z value. So for us, when we say the base, the standard Z value is the distance from the tip adapter to that point in space. So those are the actual live distances between the tip adapter and each individual X. What's also significant is not only can you see multiple points, but you can actually move these points around on the screen just by tapping. So whenever I tap, it shows you it moves the center of that reticule to where you tap. So you'll see now that this the section on the left of the reticule is at 0.5, nearly 0.6 inches away, and then on the right it's over 0.66 inches away. So you can see that this pipe is curving away from the tip adapter, which can be relevant if you want to quickly see if you're going to measure the entire image, or you have things you want to measure in the entire image. This gives you a quick indicator if that's going to be a problem or not. I'm going to tap in the center and also show that, and I have my handheld remote controller here so I don't take up more space on the screen. I'm going to press up on the zoom, and you'll see that I can change the actual size of that reticule, just to give you a better indicator of where you're going to measure and what it's going to look like. So once I am close enough, and as far as being close enough, we want to keep it within 1 or 2 green on the color bar in the bottom and the middle. So you'll see that as I take the insertion tube and maybe get a little bit closer, that green will become 1 green. So this is more preferred than 2 green, and 2 is better than 3. After 3 green, you get into yellow. With the NX, you can reliably measure with 1 yellow, but it is recommended to kind of do some remeasurements, multiple measurements with that same picture, just to verify. So I think this is close enough. What I'm going to do is jump right into measurements by, you can either press measurement on the remote controller, or I can press measure here on the bottom. And for demonstration purposes here, I'm going to choose depth measurement, but you have all these other different options. I'm going to choose depth. What I'm first going to do is look at my 3D model to see if it's a 3D model and if it's going to be useful. So I go here to menu, because the standard view is 2D, 2D. Basically, you're looking at the 2-dimensional stereo picture. Go to 3D option, and you have all these different options. I'll go through a couple of them. First, I'm going to choose the top right, the 3D option, where it shows you the 3D model with the actual picture kind of wrapped over the model. So what's really neat about this 3D model is that the NX has a large touch screen, so that you can, just like you would on your mobile phone or tablet, you can use multiple fingers to zoom in and out, take 1 finger to move it and drag around to see the actual model from different angles. You can also do things like, I'm going to hold down the menu button to get rid of those axes, because for me that just it gets in the way. So this gives you a good look at the actual model and will give us a better indicator of what we're measuring. You can even see the dips and the tops and bottoms of that weld bead right here on the model. So looking at it full screen is good, a good indicator to show us that this is going to be a good model to use. So what I'll do is go to menu and then go to 3D option, go to 2D, 3D. So here we have the 2D picture on the left and then the 3D model on the right. So you can still move this model around, and then on the left, as I move my point around, you'll see that the point is being updated on the model, so that you can, again, have a better indication of where you're picking your points on the actual model. So what we're going to do is, because this is depth measurement, I'm going to pick 3 points to give me a reference plane. So pick 3 points right here. And to see if that's going to give me a good value, what I do is go here to the 3D model and actually look at it from the side to see if it's going to be a true representation. Now, I see that for some reason, this point for me is a little bit higher than I would like or would expect. This triangle looks like it might be skewed a little bit. So what I'll do is come here and go to menu, clear last point, execute. I'll just start all over. I'll clear. So look at here, I can move this model around, and you'll forgive me, but I've been using the NX quite a while with this 3D modeling, so I may be moving it around, twisting it around pretty quickly. to give myself a good indication of what I'm measuring. So that looks pretty good to me. I will select that point and then pick another point, look at the actual model that looks good to me. I will actually pick that point. And then lastly, up here. That looks good. Looks like it's on the actual base material. And then below the weld, of course, you can already see that there is some undercutting right here next to the weld. So you can see this dip below the actual reference plane. So once I have that, my reference plane set up, what I can do is then go into our other color mapping mode. And you can now see the 3D model where it highlights the distances from that reference plane. So you'll see the little color bar to the left, the legend on the left. Basically, green says REF, stands for reference, essentially 0. So everything in the green is essentially a distance of 0 or in line with that plane. The blue is positive, so that means that it is above the plane, which obviously you would expect. That's where the weld is. And then the red is below the reference plane. So you can see, especially down here in the bottom left, you can really see that there is some relatively significant undercutting. Note that there are maximum and minimum values here, negative 25 thousandths, and then essentially near positive 20 thousandths. That gives you the maximum and minimum values, basically the highest and lowest points relative to that reference plane. So what I can do is go in here and then actually take my measurement. So it's worth pointing out that this 3D modeling is very, very helpful and very useful. But in order to generate this 3D model on the right, there is some alteration that needs to be done to the image and to the model itself. The point of the model is to help you do the measurement. The point is not to do the measurement on the model. The model is just there to give you a guide of representation of what you're measuring. Your actual measurement is still happening on the left image. So what I'm going to do is come over here and actually do my measurement on the left-hand side. As I mentioned, there is some alteration done to the model to make it look better. It basically cuts out the noise and smooths the model. Because of that, if you do an actual measurement, you may get a value that is slightly different than the maximum and minimum value. So what I'm going to do is test that. I'm going to take a point here and essentially get close to that maximum value. And I can see on the actual 3D model, I'm pretty much right on top of it and reading 0.22 or 0.022, 0.023. So it is off, but only by about a couple thousandths of an inch. Again, if there is ever any discrepancy between what the model is reading and the actual 2D stereo image, favor the stereo image, because this image on the left has not been altered. This is a raw image, so it's a true value. And then, of course, you can take a picture. You can take a picture as print screen so that you can see this image itself on any image on Microsoft Paint or on your phone. And so you can see this image as well as remeasure the raw stereo image, and they're both in JPEG form.
Hey, Charles, how do we do a question here for you? Can these measurements be done on a laptop post inspection?
They can. They can all stereo measurements taken with all of our Videoscope models can be remeasured on a laptop afterward. So basically, all the measurement you can do on the scope, you can do on the laptop. You can go to olympus-ims.com and download the InHelp Viewer software, and that software is free, and that is what you can use to do the remeasurement. Currently, you cannot view 3D models on that software.